Hello and welcome to Nkumat Online Academy. In today's lesson, we are going to learn elasticity and we are going to look at the following: the meaning of elasticity, Hooke's law of elasticity, Young modulus, bulk modulus, shear modulus, and then we look at some solved examples. Now, this is actually what you are going to look at today: a spring or a rubber, anything that we can apply a load on it, and when we remove the load from it, the thing will come back to its original form. Like our rubber, when we put a load on a rubber and remove the load, it will come back to its original shape. Your rubber band, when you put a force on it or a load on it, it will increase in length, and when you remove the load applied to it, it will come back to its original shape and length. The same thing with springs. When you add or when you put a load on a spring, its length will increase, and when you remove the load applied to it, the length will come back to its original form. So let's look at the meaning of elasticity. Elasticity is really defined as the ability of a material to return to its original size or shape when a force is applied to it, or when the force applied to it is removed. Just like I've explained before, that elasticity means the ability of a material to come back to its original shape when a force applied to it is removed. There is a scientist called Robert Hooke that first gave us the relationship that exists between the increase in length and the force applied to an elastic material. So he's the person that first of all stated what we call today the Hooke's law. And the Hooke's law says that the force applied to an elastic material is directly proportional to the extension produced. When we apply a force to an elastic material, the length will increase. The increase in length is called an extension. If the original length is 4, and when you put a load on it, it increases to 6 or 5, the increase in length, which is 5 minus 4, that is 1 unit increase in length, that is called an extension. So there is a relationship between the extension and the force, and it says that the force is directly proportional to the extension produced in an elastic material. Of course, we know that these spring and rubber, they are common elastic materials we see almost every day. So this is the Hooke's law, that force is directly proportional to the extension produced in an elastic material. And taking it like that, if we say that F represents force and E represents extension, then it becomes that force is directly proportional to extension, and the force, if we clear the sign of proportionality, becomes you put equality sign, and force now is equal to, we put a constant K extension we represent with E, and then that means that if we want to make K to stand alone, we find that K, which is the constant now, is equal to force over extension. Force of extension. Now this K is called elastic constant. It has a name and it is called elastic constant. Now this is a graph that shows how elastic materials behave when a load or a force is applied to it. Like when you get your spring or your rubber and you start putting load on it, different loads, maybe you start from 2 newton, then continue increasing the load. This is how the shape of the graph is going to look if you plot the force and the extension or the increase in length produced in the elastic material. The graph is going to look like this, showing the paths or the behavior of the elastic material when different sizes of load is applied to it. Now, looking at this graph from here, assuming that we take a unit of 2 cm at the extension side, this is the extension, and this is the force. So taking 2 cm to represent 1 unit in both sides. Now let us assume that the extension or force applied produce equal amount of extension. And that means that when we apply a force of 1 Newton, it will produce an extension of 1 cm or 1 unit here. So that is it here. So 1 and 1, we plot it here. It has a junction at this side. Now 2 and 2, we have an extension of this side. Now 3 and 3 are also supposed to have their own extension at this side. But see what happens when this material reaches this point. When it reaches this point, it bends. It is no longer following the normal path because 3 is supposed to go with a 3, since equal force gives equal, each force gives equal extension. But when it reaches to this point, the force applied is not producing equal amount of extension. So it is bending. You apply small force, which is 3, and it is producing a very big amount of extension, which is 4 at this side. So see the points it is meeting here now. So at this point, we find out that something has started happening. That means that the elasticity rule is no longer applied. The material has lost its elasticity. That is at this point. At this point, the material has lost its elasticity, which means that the increase or the applied force does not produce equal amount of extension any longer. That is when the material has lost its elasticity, and we call the point the elastic limit. So this point is the elastic limit. Now, when we continue to add more load to the material, it will continue to go like that until at a point here, at another point, we call the point the yield point. At that yield point, the material has carried its maximum load. Any applied force again does not produce any change in extension again. So the curve or the graph at this point will now flatten. So when it reaches to this side, the curve will flatten. So you apply a load of 2 Newton, the same extension is what you will produce. You apply a load of 6 extension, you have the same extension. So it becomes, the material becomes totally inelastic. It does not produce any extension when you increase the load. And when you continue to add the load again, when it gets to a certain point, this point here now, the material cannot withstand anything you are adding to it, and the material will break. If it is a rubber, it will cut. If it is a spring, it will cut. So this point that it cannot withstand any other load again, we call it the breaking point. The breaking point, the point that the material cannot withstand any load again. The yield point is the point that the material has carried its maximum load. It has carried its maximum load at the yield point. So the force you apply again will not produce any extension, and the curve flattens. It becomes straight. So anything you apply, it does not change the extension. So this is how actually the curve of force and extension looks like. And I hope that this is very clear. Now, let's look at some examples of extension. Calculate the elastic constant of a wire if it is extended by 4 cm when a load of 50 Newton is applied to it. Now, we see here that we know that the Hooke's law states that force is equal to Ka. This is the Hooke's law. From force is directly proportional to extension. We get this law. Now, using this, we put the force and we put the E extension. If we make K the constant, which is what we are looking for, the elastic constant, we say that K is the elastic constant. So if you make it the subject of this formula, it becomes K is equal to F over E. Now we divide the force by the extension, which gives us 12.5. Example 2. An elastic material is extended by 4 cm when a load of 10 Newton is applied. Calculate the extension when a load of 5 Newton is applied to it. Now from the Hooke's law, F is equal to Ke. Now what it means is that K is equal to F over E. F over E. Now assuming that you have different force and different extension, maybe you have two force and two extensions, it actually means that F1 over extension 1 is equal to F2 over extension 2. It continues like that. Assuming we have another force and another extension, it continues going like that. So we can use this to find any of these parameters. Maybe we have two of the forces and you have one extension. We can look for the second extension using this formula. This is another version of the Hooke's law. It is gotten from this. So when you have different forces and different extension, you use this formula. But if you are looking for just one extension and one force, then you use this one directly like the first one we solved. So applying this second one, the second version, now F1 over E1 is equal to F2 over E2. Now our F1 is 10 Newton and the load then is 4 Newton. Then F2 is 5 Newton and we are looking for the second extension, which is E2 now. So we say 10 over 4 is equal to 5 over E2. When we do the cross multiplication of that will give us, we have 10 over 4 is equal to 5 over E2. Now if you do cross multiplication, that means this one going to this one and this one going to this one, and that will give us that 10 times E2 is equal to 10 times E2 is equal to 4 times 5. We can now make E2 the subjects of this formula, and when we do that, we have that E2 is equal to 4 times 5 then divided by 10, and that gives us 2. Example 3. An elastic material is extended by 2 cm when a load of 4 Newton is applied. Calculate the force that will produce an extension of 5 Newton on the material. Now here we bring out our parameters. We have F1 is equal to 4 and E1 is equal to 2. Calculate the force, then F2 we don't know it and E2 we know it. Extension is equal to E2 is equal to 5. So we just use the second formula and put everything where it's supposed to be, and we have F1 over E2 is equal to F2 over E2, and that means F1 is 4 over extension 1 is 2 is equal to F2, which is what we are looking for, over extension 2, which is 5. And if you make F, which is the one we are looking for, if you make it the subject of this formula, we have that F2 is equal to 4 times 5 over 2, and that gives us 10 as the answer. So from this equation, the second equation, we get it because we have different forces and different extensions. Example 4. An elastic material of length 20 Newton, 20 cm increases to 22 cm when a load of 10 Newton is applied. Calculate the new length of the material when a load of 45 Newton is applied. Now here is a little bit tricky. Now what we are considering in Hooke's law is length. We are considering extension and force. Extension and force, not the length of the material, but its extension. So when you are given the length of the material, you find a way to get extension from it in order to use the extension and solve your problem. If you use the length given to you, you may not get the answer. It is the extension that we consider in the Hooke's law. And what is an extension? An extension is the increase in length of a material. Assuming that we have a material and the length of it is 4, the natural length of the material is 4 cm, and now we increase, when we add a force to the material, the length increases to 5 cm. Now it means that the extension is equal to the new length minus the old length, which is 5 minus 4. That means the increase in the length, which is equal to 1 cm. So it is this 1 cm, which is the extension that we use in solving any problem that is related to Hooke's law. So with that, we now start solving this. Now using the same formula, F1 over E1 is equal to F2 over E2. Now we know our elastic material. We know our the length of this material, original length is 20, and now when we add the force of 30 Newton, it increases to 22 cm to 22 cm. Now that means that to get the extension, we say the increase in length, which is the new length, which is 22, minus the old length, which is 20. So we have 22 minus 20, and that gives us 2 cm. So what we have as an extension is 2 cm, and it is this 2 cm that we are using to solve this problem. So we now have that with that we now have that E1 is equal to 2, that is extension 1 is equal to 2, and F for it is equal to 30 Newton. Then F2 is equal to 45 Newton, and we are looking for E2. Say calculate the new length of the material. Now for us to get the new length of the material, we first of all have to get the extension of the material. When we get the extension, then we add the extension, which is the increase in length, to the old length, and then we get the new length of the material. If you want to get the extension, you subtract the old length from the new length, and when you want to get the extended length, you add the extension you have with the old length. So assuming that your extension is 2 and the original length of the material is 4, now the new or the extended length of the material is equal to 2 plus 4. So let's see how we solve this one. F1 over E1 is equal to F2 over E2, which is our normal Hooke's law. Now our F1 is 30 and our extension is 2. That is extension 1 is equal to F2 is 45, F2 is 45. 45. So 45 over E2. So with this, if we do cross multiplication and solve, we get that E2 is equal to 45 times 2 over 30. You can do the cross multiplication and try to get E as the subject. You will get this. And then E, if we divide, we get 30 cm. Now the E that we have now is the extension, and we are looking for the new length of the material. So for us to get the new length of the material, we put the extension we have now to the old length of the material. Adding two of them will give us the new length of the material, which is the new length of the old length of the material is 20 cm, and we have another increase which is 3. So 20 plus 3 will give us 23. So that gives us the new length of the material. So you should be very careful to know when they are asking you for the length of the material and when they are asking you for the extension of the material. This is a very common mistake that most students make. You should be able to know when you are looking for the extension and when you are looking for the new length or the length of the material. Now we look at another example. An elastic material has a length of 36 cm when a load of 40 Newton is hung on it, and a length of 45 Newton when a load of 60 Newton is hung on it. Calculate the original length. Now this one is getting a bit more trickier, but to solve this, we are looking for the original length of the material. We don't know. If we already know the original length of the material, we can get any other thing easily. But now we don't know the original length of the material, which means that we don't even know the extension at all. We don't know the value of any of the extensions. For the first extension, E1, if we call the original length L, it means that for the first extension, an elastic material has a length of 32 cm when a load of this is applied to it, which means that it has extended to 36 from its original length. So for us to get the extension, we have to know the original length, but we don't know it. So let's call this extension, this first extension is equal to 36. Remember that extension is equal to the new length minus the original length. So the original length, we have it as L. So for the first one, the first extension E1, E1 here is equal to 36 minus L. That is E1. We don't know the value of this extension because we don't know the original length. Now E2 is going to be the second new length minus the original length. Now when we add a load of 60 Newton, the length of the material and a length of 45 cm, length of 45 cm, 45 cm, we have 45 cm when the new load is 60 Newton. So E2 now, or the second extension, is equal to 45 minus the old or the original length, which is L. So this represents the values for our E2 and E1. So we put it in the equation. So E1, F1 here, F1 F1 over E1 is equal to F2 over E2. This is our law, Hooke's law. So using F1, which is 40, then over E1, we have our E1 as this 36 minus L. So we put it there, and our F2 is 60, and L E2 is 45 minus L. We put everything like that, and so we have what you are going to have is well solved there. We have 40 over 36 minus L is equal to 60 over 45 minus L. And so if you do cross multiplication, it becomes that this one going to this, have 60 brackets 36 minus L. We put a bracket to factor this very well and expand it. So this is equal to 40 on the other side, and then 45 going to it. We put the 45 minus L in a bracket, 45 minus L. Now that is equal to, that gives us 45 minus L. That gives us 60 times 30. That will give us 2160, minus 60 times L will give us 60L. Then minus 40 times 45 will give us 1800, minus 40 times L will give us 40L. That is what we have here. And so we collect like terms. The ones without L will be on one side, and the ones with L will be on the other side. So we have it as a 2160 minus 1800 is equal to 60L minus 40L. And when we minus this, 2160 minus 1800 will give us 360, and 60L minus 40L will give us 20L. And so we solve for L, and L is equal to 360 minus 20, which gives us 18 cm. So that is why this is the answer. So this is the original length of the material. So if we want to get the extension, any of the extensions, we now say for the first one, the extension there is 36 minus 18. That will give us E1, assuming that we want to get it. They did not ask us to get it this place, but assuming we want to get it, the first extension is equal to 36 minus that original length, which is 18, while E2 is equal to 45 minus 18. So this is how to solve this, and I believe that this is very, very simple. Thank you.